Good afternoon, dear students. In yesterday's class, we discussed about the what are heterocyclic compounds, examples, and classification of heterocyclic compounds, and preparation of synthesis of heterocyclic compounds. In this today class, in today's section, I am going to discuss about synthesis of fuel. In yesterday's class, I discussed pyrrole and another fuel. In this class, synthesis of furan. In synthesis of furan, you already seen the reaction in synthesis of pyrrole. This furan synthesis only. Here, synthesis of furan. Next. Synthesis of fuel. Synthesis of furan. In synthesis of furan, there are two-step reaction. Here, two-step reaction. In first step, it is the acid hydrolysis of pentosan and use aldopentose. Then it is hydrated to give a furan. Then it is carboxylated to form a furan. This is the first step. Second step, here is used for perfural on oxidation with potassium dichromate. On oxidation with potassium dichromate gives ferulic acid. Ferulic acid, then it is heated undergo decarboxylation to give furan. This is a two steps reaction. Here I write here step 1. Pentosan C5H8O4. This is a pentosan. Here, this is the acid hydrolysis H2O H plus. This is the acid hydrolysis. Formation is aldopentose. That is CHO already group, and here CHOH thrice CH2OH. This is the aldopentose. This is the pentose. Then this is hydrated. This is hydrated. Formation is perfuran. Perfuran is formation. Here, next formation, decarboxylation takes place in this oxide at 400 meter width at 400 degrees Celsius is the catalyst. Here, carboxylation CO and 400 degree Celsius. Formation is pure. The lone pair of electron. Formation is pure. This is the first step reaction. Here, in another step, you add a oxidase, that is a dichromate, potassium dichromate. Here, this is a oxide catalysis. This is the oxide catalyst at 400 degrees Celsius. Formation is furan. This is a step 1 reaction. Next, step 2 In step 2, this perfurol is treated with oxidation with potassium dichromate. CHV, presence of potassium dichromate. K2Cr2O7. Next formation is feroic acid. COOH. His name is feroic acid. Then carboxylation takes place here, or heating, and decarboxylation here, minus CO2 to form a fuel. This is a synthesis of furan. You ask in examination 3 marks or 4 marks. Here, pentosan, acid hydrolysis of pentosan to form aldopentose, then it is hydrated. This aldopentose is hydrated to form a perfurol, then perfurol is carboxylation takes place at absent catalyst at 400 degrees Celsius to form a fuel. Then second step here, this step 2 here, this is a perfurol. This perfurol and oxidation with potassium dichromate to give feroic acid, and then it is heated and decarboxylation to form a furan. This is a synthesis of furan. Okay, next one. Next concept, properties of heterocyclic compounds. Heterocyclic compounds. Here, properties of heterocyclic compounds. Heterocyclic compounds means pyrrole, thiophene, and furan, PAD. These are the heterocyclic compounds. And the first, there are two properties here. One is the physical properties. And another is the chemical properties. Here, first one, physical properties of pyrrole. Physical properties of pyrrole. The pyrrole, it is a colorless liquid with a boiling point 131 degree Celsius. Here, first one, these pyrroles are the colorless liquid with a boiling point is 131 degree Celsius. Is a colorless liquids. First property, with a boiling point 131 degree Celsius. 131 degree Celsius. Second one, it is darkens when exposed to air. It is darkens when exposed to air. And third physical property, it is soluble in water. It is soluble in water. And sparingly soluble in organic solvent. And sparingly soluble in organic solvents. Here, physical properties of pyrrole. Here, first property is it is a colorless liquid with a boiling point 130 degree Celsius. So, boiling point here, the colorless liquids, the boiling point is 130 degree Celsius. Second one, it is the darkens when exposed to air. When the pyrrole is exposed in air, here the color is formed. Here it darkens. Next, third one, it is soluble in water. It is soluble in water and sparingly soluble in organic solvents. These are the physical properties of pyrrole. Okay, next, this second one, chemical properties of pyrrole. Chemical properties of pyrrole. Physical properties completed and chemical properties of pyrrole. So many chemical properties or chemical reactions are there in a pyrrole. First one, reduction. This first one, here reduction. Here reduction, pyrrole on reduction with zinc and acetic acid. When reduction takes place in a zinc and acetic acid form pyrrolene, without heating, then it is pyrrolene is formed. Then it is heated with hydriodic acid and red phosphorus to form a pyrrolene. Here you see pyrrole. This is a pyrrole and it is reduction takes place here, Zn or acetic acid Reduction you have to write 2H here also, and then form a pyrroline. This is a pyrroline, and this bond is to pyrroline. And then on heating with hydriodic acid with red phosphorus, Hi and phosphorus, to form a pyrrolidine. This is a pyrrolidine. First chemical property, pyrrole. First chemical property, reduction in pyrrole. This is a pyrrole. Pyrrole reduction takes place here. Zinc and acetic acid transform reaction to H, and formation is pyrroline. Then this pyrroline is, then it is heated here on heating with hydriodic acid with phosphorus to form a pyrroline. Next, here on reduction, in here the presence of nickel as a catalyst. It is heated with 200 degrees Celsius to form a pyrrolidine. I write it here only. B. On catalytic reduction of pyrrole in presence of nickel as a catalyst, on catalytic reduction of pyrrole, this pyrrole in presence of nickel as a catalyst and at 200 degrees Celsius, heated at 200 degrees Celsius, gives pyrrolidine. Here nickel as a catalyst heated at 200 degrees Celsius to form a pyrrolidine. This is the second reaction. First here is the reaction takes place in presence of zinc and acetic acid, and then pyrroline is formed. Then that pyrroline is on heating takes place, heating with hydriodic acid and red phosphorus to form a pyrrolidine. In this pyrrole, it is catalytic reduction of nickel as a catalyst here. I will take here H2. 2H or H2. H2 and nickel is a catalyst and it is heated at 200 degrees Celsius to form a pyrrolidine. This is the first reaction. Second one is oxidation. Second chemical property, oxidation. Here, pyrrole is oxidized. Use pyrrole is compulsory here. In preparation of pyrrole, then it is used in a chemical reaction, that is our chemical property. Here, oxidation. Pyrrole is oxidized to malesimide acid. Here, malesimide by chromium trioxide. Here, Cr2 goes with chromium oxide in acetic acid. Formation of malesimide. Here, malesimide formation is malesimide is a product. Here, the mixture of here, that is a chromium trioxide in acetic acid. Right. taken this is a pyrrole oxidation. The pyrrole takes place oxidation. This is a pyrrole, and then presence of here presence of Cr2O3. Cr2O3, chromium trioxide, and then presence of acetic acid, CH3COH, and nascent oxygen is present here, and formation is malacimide, double bond O, double bond. This is a malacimide. Here is H. This is a product. You consider here this is a E. Write your self-explanation. Pyrrole is oxidized by chromic trioxide in acetic acid to form a malacimide. This is a product here. Next B. This is a A. And B. You also write this file. This structure is CH double bond CH and C double bond O and C double bond O. Here N, this is H. Now this structure, write this type also. Second oxidation, pyrrole is also oxidized with sodium hypochlorite, NaClO, in base to give 3,4 dichloromalacimide. Here I taken a pyrrole on oxidation. On oxidation is sodium hypochlorite. This is the sodium hypochlorite, presence of alkali, that is sodium hydroxide, and to form a 3,4. Here this is 1, this is 2, 3, 4, 5. 3,4. This is here 3,4 dichloromalacimide. Here this is 3, this is 4. The Cl is attacked. One is Cl here, one is Cl here. Okay, this is a NH. Here next, the formation is Cl and Cl. This name is double bond O and double bond. Here name to give 1, 2, 3, 4, 5. 3,4 dichloromalacimide. This is the product on oxidation with this pyrrole. This is a B reaction. In A reaction, the pyrrole is oxidized with chromium trioxide with acetic acid. Formation is malacimide, and here the pyrrole is oxidized with the sodium hypochlorite in presence of NaOH to form a 3,4 dichloromalacimide. This is a second oxidation reaction. next is this is oxidation, reduction is completed, oxidation is completed, and third one is electrophilic substitution reaction. This is a very important nucleophilic and electrophilic. Here electrophilic substitution reaction. Third one, electrophilic substitution reaction. In this comes under here sulfonation, nitration, halogenation. These are the electrophilic substitution. Here first one is here A, halogenation. Halogenation. This is the first reaction. Sorry. Here halogenation used pyrrole here. Pyrrole is when treated with pyrrole is treated with bromine. You take halogen and bromine, chlorine. Yeah, any you have to take here halogenation. First one, pyrrole is treated with bromine in acetic acid. It undergoes substitution reaction. Here it undergoes substitution reaction to give 2, 3, 4, 5 tetrabromo. Here I write here. This is a pyrrole. In presence of halogenation, that is the 2Br2. Here is the presence of acetic acid to form NH, and here Br. This is a Br and Br. This is a Br. 1, 2, 3, 4, 5. This name is here 2, 3, 4, 5 tetrabromo 5. 2, this 3, this 4 and 5. Name is tetrabromo 5. This is the third reaction, electrophilic substitution reaction. This is a pattern. You write compulsory, write in the examination name of the substances. Any reactant or any reagent you have used it, name that complete name. Compulsory you have write name here. You know this is the halogen, right? Yourself. Next, this is the halogenation. Okay, next B. Next B. Nitration. Nitration means HNO. Nitration. Here, when pyrrole is treated with nitric acid in acetic anhydride, and pyrrole is treated with nitric acid. Nitration means using of nitric acid in acetic anhydride at 0 degree Celsius to form a 2-nitropyrrole. Here, this is a pyrrole and it is treated with nitric acid plus HNO3, nitric acid with acetic acid. This is a nitric acid. The formation of this NO is added here 2-nitropyrrole. This is the 2 nitropyrrole is formed. Here in the we write a 0 degree Celsius and in terms of acid and nitrate. CH3 CO plus this is the acid and this is a nitration. Next, sulfonation. Next, sulfonation. Here, sulfonation is using H2SO4 and pyrrole is treated with this is the pyrrole. When pyrrole is treated with sulfur trioxide, I may also use it another reagent to form a sulfonation means using of sulfur trioxide and formation is pyrrole 2 sulfonic acid. 2 means they are taking of this second position. Here this is the first position and this is the second position. Here, pyrrole is treated with sulfur trioxide in presence of here pyridine. It undergoes substitution reaction to give pyrrole 2 sulfonic acid. Right here, plus SO3 sulfur trioxide, sulfur trioxide. Here, presence of pyridine and form 2 pyrrole 2 sulfonic acid. Here the attack of this SO3 H1. N H SO3 H. This is a pyrrole 2 sulfonic acid. Pyrrole 2 sulfonic acid. Here numbering will do 1, 2, 3, 4, 5. Pyrrole, this is the pyrrole 2, numbering 2. SO3 group is attached to second position, that is a sulfonic acid. Right, this is the C. These are the electrophilic substitution reactions. And other reactions, Friedel-Crafts reaction, fourth reaction here, FRIE. Friedel-Crafts reaction. Here presence of pyrrole. Here when pyrrole is treated with acetic anhydride, it undergoes substitution reaction to give 2-acetyl pyrrole. This is the pyrrole NH, and it is treated with acetic anhydride AC2O. This is the CH3CO twice O, acetic anhydride. You also take SnCl4 in chloride. A stannous chloride here. Stannous chloride. Then formation is here 2-acetyl pyrrole. Then H. Acetyl chloride. Here acetyl chloride means that is the CO3. This is a acetyl chloride. So this is CH3. This is a pyrrole. And pyrrole is treated with here acetic anhydride in presence of stannous chloride, and the formation is 2-acetyl pyrrole. 2-acetyl pyrrole. Okay, next. This is the fourth reaction. Next, fifth one. With one Gattermann-Koch reaction. That is a Gattermann formulation, or many other reactions are there. You write yourself, you study yourself. I am discussing only some important reactions. Third one, Gattermann formulation. Here, sorry, fifth one, Gattermann formulation. Here, Gattermann formulation, and pyrrole is treated with hydrogen cyanide in presence of hydrogen chloride to form a 2-formyl pyrrole. Here, I take a this is a pyrrole, and presence of HCN, hydrogen cyanide, plus HCl. The formation is, that is a 2-formyl pyrrole. This name is 2-formyl pyrrole. In the presence of this alkylic group here, this is a pyrrole. You write explanation here, and pyrrole is treated with hydrogen cyanide in hydrogen chloride. It undergoes substitution reaction to give 2-formyl pyrrole. This is a fifth reaction. These are the chemical reactions of pyrrole. In this, I stop here only. In next class, I discuss chemical properties of furan, theophene, and other pyridine. These are the physical and chemical properties of remaining. I discuss tomorrow class. Thank you.